1, 2.
Oh, I see that somebody is recording. Igor, is it you?
Yes, let's start.
Okay, let's start. So let me introduce myself briefly. My name is Igor Minyaila. I'm software architect from Magento, and I'm part of community engineering team. Today's talk and today's demonstration would be purely for developers. It's gonna be purely technical talk about CQRS and event sourcing by examples of multi-source inventory. So the new inventory system, which was implemented with the help of our Magento community, and actually that was a project driven by community. But let me start the discussion from classical and layered architecture, and we will I will make an excursus of what of how Magento architecture evolved through years, from Magento 1 to Magento 2, and what actually changes in code we experience, and actually we're still experiencing. And you probably know that Magento 1 was a pretty good example of classical and layered architecture. And when we're talking about web, we usually have three layers architecture: layer of presentation, business logic layer, and the data access layer. And in Magento, we have a presentation layer represented by block classes, application processing represented by controllers and module classes, and data management function represented by resource model classes. And all these layers are physically separated. So in our case, we have own namespaces, we have own structure where we collected all the corresponding classes, and all of these corresponding classes were responsible for particular business function. And the main characteristic of the unlayered architecture is that all the requests, both read request and write request, coming from clients, actually were passing through all the layers of our system. So we did not have, and we still don't have difference of processing read and write request, and both read and write request going through the same layers of Magento architecture, coming through the representational layer, coming through the business logic layer, and the data access layer. Moreover, we have the same entities. For example, we have the same model, which will process both read and write request. Having that, we stuck with the limitation that we have the one and only model, which would be used for all different business purposes, for retrieving data, for updating data, for deleting data. So we are creating particular classes. In our case, that models, and these models would be overwhelmed with business logic, and this actually introduce a lot of complexity for our models, because the main models getting expanded, and we introduce more and more business logic inside, and they became kind of this ring of the Sauron from Lord of the Rings. So this became really monolithical. And in Magento 2, we introduced a dependency injection. And the dependency injection actually made explicit a lot of stuff which were implicit before that. So nothing stays buried forever. And introducing Magento 2, we made all the classes to say explicitly what the external dependencies they are relying on. So since Magento 2.0.0, all the classes have a contract, has a constructor contract, saying declaring all the list of external dependencies which this particular class will use in all the possible business cases. So that's why actually that will show us that we have some violation of some object-oriental principle. And here you can see the contract and the part of constructor of one of the model we have in the code base. And actually, we had the same issue in Magento 1. But since Magento 2, this issue became more evident, became more visible. And people who used to work with Magento 1 were really curious and really excited seeing these contracts in Magento 2, but actually the same dependency madness we have in Magento 1. The one exception that this dependency were not evident and the contract was not truly declared by entities. And actually, the same big ball of mud. So, big ball of mud is a phrase which is usually used by Martin Fowler. So we got the same big ball of mud as a interlinkage of our components. So and interlinkage of our modules. So not just on the level of classes, but also on the level of modules. And starting from Magento 2, we introduced design documents which we call the DoD definition of done. And we start to compose this document based on the rule which we consider must be used, writing the proper code for Magento code base. So seeing, like, as I already said above, dependency injection show us and make evident a lot of stuff which was not clear before and which were not so evident. And along with such contract, we also introduce the performance problems, because as you probably know, in Magento 2 we have constructor dependency only. We don't have setter dependency. We don't have property dependency. We have constructor dependency only. And as you can see, for example, this object which accepts so many parameters. Actually, for us, it means for our dependency injection mechanism, for our object manager, actually it means that all these external dependencies should be created before we will actually create this object. And not just all of this dependency, but also dependency of this dependency also should be created beforehand. Moreover, dependency of dependency of dependency should be created. So we need to create quite a lot of objects just to create this particular object. And we are not sure that all of these dependencies would be used. And this is actually the case for us, because for some of the scenarios, we did not use many of the external dependencies for some of the scenarios. But because we use a constructor dependency injection, we need to pre-create all of the external objects. And that's actually the reason why in Magento early stages of Magento 2.0, we got some issues with the performance, because comparing with Magento 1, where actually we used Mage get model, Mage get singleton. So we used so-called lazy loading, and we created the external dependency right in the place where we needed them. So instead of this mechanism, we introduced a constructor dependency injection, which start to create all the dependencies beforehand. And our violation of contract and violation of good architecture in Magento 1 introduce a performance degradation for our code in Magento 2. So starting that period, we decided to strictly follow solid principles, and actually solid came for us as a rescue. And actually one of the rule, the first letter in a solid, actually responsible for single responsibility principle. And the constructor of the class I was showing you 2 slides before that is actually this is the object which can be considered as a Swiss Army knife, because probably this object, this model, is really heavyweight and is overloaded with additional logic, and probably it makes sense to decouple that object and create several other independent objects which can be used for each particular business case, but not to introduce a GOT object and require it in any situation when most of the external resources even not needed to process particular request. So we start to follow the single responsibility and of course all other letters in a solid, and we declared that object decomposition must follow the solid principle for the all newly created code, and for all the code refactoring which we have, we must to follow the solid principles. And actually that was the first item we added to guideline, and I really recommend you to when you write your own logic, whether you're a Magento developer, whether you're extension developer, or you're a system integrator, I really recommend you at least to get awareness and read Magento technical guidelines, because in this document, it's not really a big one. We describe all the high-level architectural recommendation, how we recommend you to write the code, and what design principles we recommend you to follow. And after that, we also considered that the CQRS principle could be used as well, because the CQRS principle is the one which really good correspond to object, to OOP, OOD, and solid. And the CQRS principle, the common query separation, is is not very new. So it was introduced by Bertrand Meyer as a part of his pioneering work on Eiffel programming language. And actually the principle is really straightforward and pretty simple. The principle states that method should be either command, which performs an action, or query that returns data to the caller, but not both. So in other words, asking a question should not be change the answer. So how does it look in code? In code, it looks like that we have an object. In the scope of this object, we either have queries or command functions. So for example, in this case, you can see that we have a user account and we have a query, which is active, which just returns the state. So it returns the state, but actually does not affect the state. And we have a command activate, which actually changes the state. So activate makes the state as active, but it does not return the state. So it returns void, which is pretty common for all the command operation. So here on the slide, you can see the main characteristic of the CQRS principle. So what's also is very important here, that all of these methods are still in this still located in the scope of one object. So all the differentiation here is made on the level of method, but not on the level of object. And here we come to the CQRS, which looks like just one more letter added to the CQS, but actually it's a little bit more than just one more letter. So the CQRS stands for the Command Query Responsibility Segregation. And if you'll see our Magento technical guidelines one more time, you will actually see that the application should be structured in compliance with the CQRS principle. So we apply the CQRS principle, and we recommend, because you see that when we mention solid, we use must, but reference the CQRS, we are using should here. So we really recommend to use the CQRS as a way to segregate boundaries of application when developers and when Magento developers would be structuring the application. What actually CQRS means? So referring to Greg Young, so Greg Young is a guy who introduced the term CQRS. So he mentioned that CQRS is two objects where there previously was just one. So it's very, very easy. Nothing can be simpler than that. So in traditional approach, we had, like in Magento 2, in Magento 1, we had traditional approach like a 3-tier architecture, and everything goes in and out through the one entry points, and all the classes are used. In a CQS, we still use entry point on the level of class, but we have different method. Some of them responsible for command processing, another responsible for query processing. With the CQRS, as Greg Young mentioned, instead of one object, we introduce two objects. So it's very simple. And one object responsible and one class responsible for command implementation, another one responsible for query implementation. So really simple design approach. So CQRS as simple as to draw an all. So you just need to draw some circles, and after that you draw the rest of the all. Actually, it's not so easy to implement proper CQRS solution. Probably it's not so easy as to draw an all. And actually, the reason why it's not so easy, because applying the CQRS, you should think about the design of the domain model first. So if you are familiar, if you don't familiar with the domain-driven design book written by Eric Evans, I really recommend you to stop listening this presentation and read this book beforehand, and after that continue watching my presentation on YouTube, because it would be recorded and uploaded to YouTube. But I hope you're already familiar, because this big blue book could be considered as a Bible, because it's introduced quite a lot of basic understanding how to write how to write software for really big and sophisticated domains, as for example e-commerce. And actually, when we want to build a CQRS system, we need to first to think about our design, about our domain design, and what the domain operation and domain processes we have in our system. So on this diagram, actually, you see that how this segregation happens. That, for example, you have a Magento UI, and all the commands will go to particular part of the application. This particular part is where you would have domain-driven design. So that's gonna be some command creation, and this command creation would be processed by domain model, and we would have there some pretty sophisticated validation mechanism. We would have there pretty sophisticated domain models, and quite a lot of objects processing this request. And afterwards, the result of this particular business transaction would be persisted in a durable database. In our case, it's going to be MySQL database, and here how we process the command. And in other word, in another scenario, we could be interested to grab the data. And actually, this is so-called read scenarios. And the read scenarios are much more frequently to occur than the scenarios when we need to affect the data, when we need to persist data. So because usually the principle of Pareto, so 80/20 works here. So we have much more read queries comparing with write queries on e-commerce stores. That's why, but for querying data, actually we no need to have really sophisticated and big domain model. So all we need to do is just to grab some data from database. Actually, it could be even database which is optimized for reading. So it could be MongoDB, for example, but not relational database. It could be Sphinx. It could be Elasticsearch. It could be Redis, and we can just grab that data and not wrap this data with really sophisticated domain models, because all we need to do is just retrieve the data out of, let's say, out of MongoDB, and push this data to our template, just to provide an ability to render data. We now need at all the validation step here, because we consider that all our data, which is stored in a database, is already valid, in a valid state. So we just need to apply the validation step at the time when we going to apply some modification to the data. So we need to apply this at the time of the command processing, but not at the time of the query processing. That's why we see here that, that's why we see here that querying model is really tiny comparing with the command model, which is pretty big one and sophisticated and the resource consuming. And actually that's not even all. So when we're talking about the CQRS, we need to consider that command works with business intent, not just a record. So we are not considering our operation, and we are not considering our system as a book of records. So because we're working with a business intent, and we are having and processing all the business operation and business requests, but not working kind of with a table of record where we changing some attributes. So all the data modification happen in the system happen as a result of business transaction. That's actually why CRUD style is not recommended and not compatible with the CQRS. And how you can consider that what you will actually get if you will decide not to use CRUD style of operation. Everything will change in your application, starting from the API, because you would not have something as a repository, for example, in our case, because our repository actually created for CRUD operation. But the main difference would be even in interface. So user interface would be really affected if you will decide not to use CRUD, but decide to use CQRS approach, because your user interface will actually represent the business, but not all the particular changes in attributes which merchant can apply for all the possible entities. So let's consider an example. So here you can see the Crowdbase UI, where there is some form which provides an ability to change. For example, it could be a Jira ticket, and it's possible just to edit all possible attributes of the Jira ticket, starting from title, description, assign to attribute, and assign at. And here is how you can update all the possible attributes. This is actually pretty similar to Magento grids we have in admin panel, because actually Magento grids consider the entity as a record in database and provide you a more fancy way for our merchant to change the attribute, but actually the idea is pretty the same. So we consider actually UI represent, this approach is called like forms over data. So our UI is just more fancy UI over the relational database way how the attributes could be changed in a table. And contrary to the CRUD-based UI, we can have a task-based UI. And in a task-based UI, the similar task can be implemented like, let's say, different buttons, and each button represents particular action So here we can assign people to the task, or we can complete the task, or we can make some editing. For example, if we press the button assign because we want to assign some people to the task, the modular window appears where we can specify the name. And as a result of this operation, we would not just update the attribute of the assignee for this particular task, but we would create a command, and this command could be processed asynchronously later. And as a result of this command processing, afterwards we will finally update the assignee attribute for this particular task. So this is a totally different way how the UI could be represented if we decided not to use the CRUD UI in favor to use the CQRS UI. And a very good example of the task-based UI, or how the guys in Microsoft call it, inductive user interface, is a control panel in Windows. Because if they just imagine what the disaster is gonna be if in Windows they, or in Mac, for example, they propose not to change the some particular setting based on your own user's intent, but just provided some kind of tables where users supposed to find the proper attribute and manually change it. It would be a disaster. But now, having the intent, for example, to change some setting of my sound card just to make the sound louder, I come to this basic screen, and I see the sound, and after that I go to the adjust system volume, and I'm done. So I'm not having a lot of grids here, and I'm not looking for a particular attribute which is supposed to be configured just to get the same result, but I'm following by my intention. And here we come, as I already mentioned, and I show you how the command for assigning customer for particular ticket could be created. I mentioned that the ticket could be processed asynchronously. And when we are talking about asynchronous process, and when we are talking about scalability, we always need to mention about the CAP theorem, because the KAP theorem is a ground-based theorem for all the distributed system. Now, especially starting from Magento 2, because Magento 2 started to be more mature than Magento 1, and the main requirement for Magento 2 was to be compatible with enterprise business, with merchant, with bigger catalog, with merchant who have more transactions than comparing with those merchants who use Magento 1. So actually, this introduced for us additional technical requirements for scalability, first of all. And if we are talking about Magento 1 architecture, it was n-layered, as we already discussed, architecture based on a seed compatibility. So you can see here what it actually means. It means that in Magento 1, we used to have strong consistency and strong availability. And actually what CAP theorem says, that there are consistency, availability, and partition tolerance, and you can choose just two of these properties. and it's not possible to get 3 of them. So there is no intersection of and overlapping of 3 of these circles. There is a possible to get just an overlapping between 2 of them. And you can see that having a system with a strong consistency and availability, actually you lose the partition tolerance. What it means that Magento 1 can't effectively scale. And we'll talk a little bit more about scalability later. But what is important for us here at this stage, that scalability was a bottleneck for Magento 1. And usually scalability for Magento 1, and actually it was pretty typical schema when replication, especially master-slave replication, was used, and there was one master and many slaves. But when it comes to scalability of master, so the scalability of the part which is supposed to affect the data, our command operation, it was also a problem. And now in Magento 2, it was made a decision to go towards the base paradigm. So what is actually ACID? So ACID is atomicity, consistency, isolation, and durability. So actually, this is most of the properties of the transactional system in a relational database management system. So you probably know about ACID if you know about MySQL transactional mechanism. But if you want to build a system which would be operated on several physical nodes, on several physical environments, like independent servers, it wouldn't be possible to wrap all of that processing in one database transaction. There are some particular mechanism, as for example, 2-phase commit or 3-phase commit, and even MySQL provides the support of the 2-phase commit, but it is very sophisticated solution, and also this solution does not guarantee, so the 2-phase commit doesn't guarantee that the system will get into the consistent state after the transaction execution. And such sophisticated mechanism introduce quite a lot of pitfalls, and introduce quite a lot of performance degradation, because we introduce a system, we check whether the transaction completed on all of the nodes. So it's pretty sophisticated, and we will have a lot of network communication with this process. So as a result, modern distributed system started not to rely on the consistency, but to choose the partition tolerance and availability instead. That's why such concepts as a base, so base stands for basic availability, soft state, and eventual consistency, appears, and many software architecture start to follow the base principle instead of the ACID. And later we will talk that CQRS with event sourcing is actually a representation of base principle, but not the ACID. And exactly the base principle we applied in a building of multi-source inventory system in Magento 2. So eventual consistency. Actually, this is a reference to a pretty dated design article, but it's really actual in the nowadays. So you can read it still. And the name of their article, Starbucks does not use a 2-phase commit. Actually, the article tries to show that this is actually mentality of most of software developers, that a seed is the only correct way to have the data consistency. But in most of businesses, eventual consistency is more natural and more proper way of doing things. And for example, Starbucks was taken as an example where client make an order, and a guy on a cash desk who receives this order immediately provide and immediately transfers this order to barista who start making a coffee. And there is potentially a situation when the client will change his opinion, and he will decide to order not a latte, but cappuccino, for example. And barista will switch to and a guy who receive an order will switch to barista immediately and ask to prepare not a latte but cappuccino, and probably barista would be already in the middle of process of making latte, and this latte would be potentially even spoiled if nobody after this guy will decide to order a latte. But still, this is a business model where the eventual consistency and the possibility to lose some data works perfectly well for real business. So just imagine what would be if a client who makes an order will, let's say, open a transaction to the guy who receives that order. That guy who receives that order transmits this request to barista, and the system would be blocked until the time when barista will finish the cappuccino, for example, and provide this cappuccino to a guy who on a cash desk, and after that the guy who actually ordered the coffee. So the whole system would be blocked for quite a long time, and that would prevent for all the clients who are waiting in the queue to make an order. And now let's consider how the CQRS applicable for the network transaction, and how the CQRS could be applied over the HTTP. So we have the get safe request for query, and we have the post, put, delete, and patch not safe request for command. So CQRS works perfectly well with RESTful architecture, but moreover, it is pretty interesting because if we consider the CRUD operation and the CQRS, so currently we make the change of the data with the put query, we make the removal of the entity with the delete query, and we create the entity with the post query, post command. But applying the CQRS principle, you can actually end up with the only post query, because you will just create a command, and that could be a command for a result, and the result of that command would be to remove entity, or to update entity, or to create entity. But actually, what you do from the HTTP standpoint, you just create a command. So the CQRS web API could be slightly different comparing to what we used to have with the CRUD web API. And the CQRS and MVC. So you used to have such implementation of MVC in Magento 1, when we had the only entry point controller, and the same controller was used for both query operation and for command operation. Moreover, in a query operation, we manipulated with the same models because we did not differentiate, we did not segregate models for query and for command. We had these pretty big domain models, which were used for both query and command operation. So we used to have this schema and this architecture of MVC in Magento 1, which was, of course, incorrect from the CQRS point of view. And we are not using this architecture anymore since Magento 2.0. In Magento 2.0, we use this schema where we send post requests to controller. This controller use particular model to modify the data. And after that, we got a response, like with a, for example, if we create entity, we respond with 200 response header, and we provide the link by following this link. User can retrieve the representation of this entity. And so now instead of one query, our client supposed to have two different queries: post query for updating the data, and afterwards, following the redirect link, we can retrieve the representational state of this particular entity. And now we started to follow this MVC approach. And if you use this MVC approach, we consider it as a correct one. And if you follow it, this guy, who is our director of all architects and who represents the architectural organization, would be really satisfied. Actually, you can read on Anton's blog about the MVC, HTTP, and CQRS, and how the CQRS can be applicable. How to build proper MVC using the CQRS approach and the CQRS architecture and the CQRS layer boundaries. Now we will talk about the CQRS and the event sourcing. So actually, when we are talking about the event sourcing, we are saying here about the event log, first of all, and all that commands which are created and sent to our application layer are saved into the event log storage, and ideally events from the event logs are never removed and never varnished. And actually, the idea behind this concept that we can build the state of our application for any particular point of time. This is especially useful, for example, for application which works with money, especially for finance, banking sector. And for example, if you have some issue with your bank account and you expected to see more money on your bank account that you actually have, you can make a call to the support, and you will when you will ask the guy on the support, the guy on the line, why do I have so a few money and I expected to have much more? The guy will check. The guy would not say you that I have a database and the cell in a table gives me the number. He actually will check and apply all the transactions you made for recently, and tell you why actually the final number is so less. Because probably you forgot about some transaction, or maybe your wife made some transaction with your credit card and you're just unaware about these transactions. So all of this state is built upon all the transaction made. And ideally, this transaction never, these events are never removed from the system. And so this is actually the pros which can be gathered applying the CQRS and the event sourcing. So you have a history, you can rebuild the state for every given point of time. You have a high scalability because all the operation, all your transaction is append only, and you no need anymore to make really big computational logic at the time, for example, when customer make an order placement. Because before that, order placement was, and actually still is, a bit heavy operation because we need to make a lot of checks, etc. And after that, we need to initiate payment transaction. We need to wait the result of the external system which approves that transaction. But making the append-only operation makes the system to operate really fast. Low latency writes and allows asynchronous processing. And actually, asynchronous processing gives us an ability to postpone all the heavy computation when the customer will already leave the site. So we process the payment, for example, and afterwards we start processing all the heavy computational operations afterwards. Now let's talk a little bit about the microservice architecture, which is also you can see some result application of the microservice architecture in MSI, and the microservices is the next step towards of Magento 2 development and Magento 2 design. So that's why it's really important to understand the way where Magento 2 is going. And microservice architecture can be considered as an alternative way of building application to monoliths. And Magento, as we already discussed, Magento 1 was a really good example of the monolithical system. So here is the book which I really recommend you to read if you want to make a deep dive into the microservice architecture and how to build precisely the microservice architecture. So if we're talking about the monolith and the microservice, especially from the scalability standpoint, you can see that, for example, Magento 1 can be scaled just replicating the whole box with Magento 1. So even if we have the bottleneck, for example, in a checkout process, we still would to deploy the whole Magento instance. Even if we don't need some resources, for example, for search or for catalog or for reporting, we'll still need to deploy all of the box with a whole Magento representation, because this is how Magento 1 is scaled. But if you're talking about microservice approach, here we can allocate more particular resources for particular services which should be scaled. So here you see that we scaled particular services, but not replicate the whole instance of Magento. This is much better from resource provisioning. It's much better from usage of allocated resources. So none of our resources would be idle, and all of the resources would be reused. So it's much better from SaaS perspective, because merchant will pay for utilization of the resources. And when we're talking about the microservice approach, we need to mention a Conways Law. And actually, Conways Law is really important for that's probably this is a ground-based rule for microservices, and the Conways Law says that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. And you probably know that in Magento 1, our organizational structure was divided on layers by means of responsibilities of people. So we had quality assurance engineer represented one layer. We had the UI specialist represented by another layer. We have a PHP developers, that was a major layer because we mostly have PHP developers, and we had several DBA experts. And all the PHP developers actually were responsible for different parts of the system. And that actually made a result of producing eventually a system which could be considered a big ball of mud, because we have quite a lot of interlinkage, and we have a system with a really big coupling and low cohesion. And that was actually an idea to make a cross-functional teams, and that was a step made in Magento internal structure, and Magento internal structure start to represent cross-functional teams, and these teams are responsible for particular functionality in the system. So we have teams responsible for different modules or domain areas, and actually such structure supposed to create the correct boundaries and correct dependency between other domain boundaries. For example, like catalog, checkout, inventory. All of that's supposed to introduce the correct dependencies, because there is an ownership introduced on a level of teams. So a group of specialists who understands particular domain better than others. And what is very important from the microservice standpoint, that each of the microservice supposed to have own database. So if the microservice still has the same database, it would be not a microservice, it would be microlith in this case. So there is a monolith, it could be microlith, and it could be microservices. So now let's discuss what the implementation of all of these architectural design approaches we have in MSI. So let's just briefly describe what is MSI. So it would not take too much time. So actually MSI stands for multi-source inventory, and the idea to introduce MSI appeared probably 2 years ago. And the idea was because as you know, before MSI, Magento was a single stock system, and we wanted to provide an ability to manage stock on different warehouses in Magento. And also there are different types of sources. It could be warehouses, it could be brick and mortar stores, it could be distributed centers, it could be drop shippers. And the request for MSI gets more and more common from our developers, from our merchants, because initially we get this request mostly from the B2B merchant, but for recent years, because the Magento 2 started to be more friendly for big merchants, we started to get the request for MSI even for B2C segment. That's why we decided to implement multi-source inventory as a part of the B2C. So it would be, it's supposed to be available for both B2B and B2C merchants. And actually, this is how the initial acceptance criteria for MSI story looks like. So as a merchant, I want to manage stock in multiple locations so that I can reflect my physical inventory in Magento without extension or customization. So sounds simple, but that was just the beginning of a really long story, which is actually still continue. And a little bit of history. So here you can see the initial epic, because initially the MSI, the first name for MSI was MNI, multi-node inventory, was created internally, and the internal team, whose name is Dragon, was tried to implement MSI 3 times in a row. So we tried to implement MSI 3 times in a row, and because of different issue, we postponed this process 3 times in a row. And afterwards, we decided to make an implementation with the help of community contribution. But actually, the main problem we stuck internally was the performance degradation at the time of the order placement, which can be controlled at all, as computation of source selection could be very time consuming. So our initial implementation was made the way that we introduced the source selection algorithm. So that at the time of the order placement, Magento supposed to make some kind of the calculation and provide the sources from which the order could be fulfilled. So provide the sources. So by means of sources, we can call warehouses or stores. So we call this entity as sources. So at the time of the order placement, Magento provided a list of sources which supposed to be used for order fulfillment. And for these sources, we made a stock deduction. And we got just incredible performance degradation, because taking into account, for example, just consider that you have one item in quantity of 2 in a shopping cart, and there are 2 warehouses. Each of these warehouses can allocate this product. So even for this, the simplest case, there are 3 variations how this order could be fulfilled. So we can make the whole delivery of 2 pieces of this product from the warehouse A. We can make a full delivery of this product, 2 pieces of this product from warehouse B, or we can split and make a delivery of 1 piece of this product from warehouse A and another piece of this product from warehouse B. So there are 3 variations for the simplest case. And if just imagine what will happen if we have, say, 20 or 30 products in a shopping cart, and we have tens of sources created. So the number of variation is just incredible. It's just huge. And if you're talking about the B2B, when the shopping cart can contain up to hundreds of products, the number of variation is just infinite. So it wouldn't be possible to wait till the end of checkout, because our checkout process will run infinitely, and probably customer can die beforehand before we will process an order. So that's why we understood working on a core that ACID is not compatible for us. It actually doesn't work for us. Even if we would have really performance-friendly algorithm, we would not even control the performance degradation we introduced at the time of checkout. But for us, it was really important not to introduce any performance degradation at the time of checkout, because checkout must be very fast. So that we decided to apply this is actually why we decided to apply CQRS and event sourcing, because the business dictated us that we are not allowed to apply the ACID with the transactional consistency and the high durability. And so let's back to nowadays, and let's discuss what we actually end up with and how currently the architecture of MSI looks like. And when we're talking about MSI, we need to consider that MSI is an example of the good code and good Magento 2 practices. And many people from community now consider MSI as a good example of Magento 2, which can be found. So just to show that MSI is a pretty big project, just in numbers. So we had 70 different individual contributors who represent 16 different agencies and who submitted for us more than 600 pull requests. Small technical overview and the size of the project. So currently MSI contains 33 modules, and MSI represents approximately 12% of the whole Magento modules code base. So just to make a short introduction, as I already said, in MSI we have such a base entity which represents source. In our case, source is can be considered as a warehouse or brick and mortar store or distribution center or drop shipper. The sources are combined in virtual aggregation. This virtual aggregation we call stocks, and the stocks are sales channels. When we say the sales channel, in Magento, we have implementation of the sales channel as a website, but potentially, for example, for B2B, the sales channel can represent the customer group, or in a project where we export the catalog data to Amazon, for example, sales channel could be considered as a catalog. But currently, out of the box, we have the only implementation of sales channel implemented by Magento website. So any sales channel, so any website, has one and only stock assigned to it. But along with that, one stock can be reused by several websites. And in technical implementation, our stocks can be considered as an index. So, for example, you can have 3 different warehouses, like warehouse 1, warehouse 2, warehouse 3, and all of these warehouses are combined together for this particular UK stock. And when we say combine, we actually mean that quantity for particular product would be just summed up, and we will get an aggregated quantity for this particular product in this particular stock. And now regarding the boundaries, and now regarding the what actually is a command and query operation and in MSI. So as I already told, it was not possible for us to process an order if we apply the source selection algorithm at the time of the order placement. That's why we decided to follow the event sourcing approach, and we decided to create a command. And in our case, command is represented by reservation. So, which is append-only operation, and which is created at the time of the order placement. So this is actually how this process looks like. For example, let's consider we have 2 warehouses. This warehouse is combined in one stock, and we have quantity 5 in France and quantity 10 in Italy. Altogether, we have 15 items, and we call this quantity the saleable quantity. And there is no any reservation yet. After that, customer comes and buy 5 products. And what we do, we just create a reservation. At this moment, we don't have any clue from which warehouse we will process an order. We will fulfill an order, so we don't make any computational logic at this point of time. All we do is just create an append-only reservation. That's why the order placement works really fast, and we are not affected with the number of sources assigned to this stock, because at the order placement time we are working with the stock, and actually this means that our system is agnostic to the fact whether it is multi-stock or single stock, because we are working with the stock, and the stock is a level of abstraction, and it hides the reality how many sources we have under the hood. So you see that we just created a reservation and our sellable quantity. So we have a service which calculates a sellable quantity, and sellable quantity provides a value like get the data from index from our state 15 and apply all the reservation. So 15 plus minus 5 will give us 10. So the sellable quantity is 10. And now, for example, the customer decided to return 3 items of this product. And taking into account that we still didn't have a decision from which sources we will fulfill the order, we just create another reservation, getting back 3 items of this particular product. And now our sellable quantity is 15 plus minus 5 plus 3, which give us 13 as a result. And after that, admin make a shipment, and he actually make an invoice and make a shipment just to fulfill an order. At this stage, we run the source selection algorithm, which can be pretty heavily, which can take some time because it can introduce some computational logic, especially if the algorithm there is potentially can be like minimal delivery costs, which is time consuming. But out of the box, currently we have the priority based algorithm, which is pretty fast to run, but still it can take some time. That's why we run it already afterwards. So we run it at the time when an order already placed, and moreover it's already invoiced. So the one who will wait for result of the source selection algorithm is merchant or admin, but not client, but not customer. So in this case, we create the compensational reservation, and we made a decision that order would be fulfilled from France. So we update the quantity for French warehouse, and as a result of it, we also rebuild the index. So now in our index, we have 13, and that's why we had to create a compensational reservation. So we have our saleable quantity equation looks like 13 plus minus 5 plus 3 plus 2, which give us resultant value as 13. And then we have a process. So this is actually how our reservation look like in a system. And this reservation can be considered as an event log. So we have a cron job to clean up all the reservation, but also we consider that some of the merchant can consider it useful to save this reservation and not remove it like in a typical event sourcing system, but potentially here the process has this removed. But this is up to merchant whether they need to run this cron job or not, because reservation, taking into account that we have a compensational reservation would not affect since the time on the total number of the saleable quantity. And here you see that we get back to the previous state. So our step 9 is exactly the same as the step 1. And this is how the eventual consistency works. So we did not have immediate consistency as we usually have with the ACID, but our system get into the consistent state after some time, like on a step 9. And here the examples how what the extension point on MSI. And also another very important part to mention, that on MSI we make differentiation between modules. So we make a segregation between API modules, between implementation, so modules which contain just implementation for the APIs, and also we make a segregation between admin UI and front-end UI. So typically for such module as inventory, we have, for such functionality as inventory, we have 4 different modules. Inventory API, which contains all the service layer and all the API provided by inventory. We have inventory module, which provides the implementation of business logic for the inventory API interfaces. We have inventory admin UI, and we have, so the UI supposed to be used in for admin area, and we have inventory front-end UI. So the main idea here why we have a differentiation between admin UI and front-end UI. So probably we can later we can use different stack of technology for admin UI and front-end UI. For example, for front-end UI we would use a PWA stack of technology and PWA Studio. But for admin UI we would still use the UI components, because we already have quite a lot of UI components like grids, and for many operations they're pretty handy. And that's why we consider that it's potentially possible to have different stack of technology for admin UI and front-end UI. That's why we make a segregation on the level of modules between admin area and front-end area. And here you can see also the positive outcome of this, that you can deploy Magento with MSI as a headless and use headless MSI only. Because, for example, MSI is such a functionality, so inventory is such functionality when merchants usually make an integration with an external ERP system, and they no need to utilize any UI on the level of Magento. Because they will use UI in this third-party ERP system. And the really good example of this kind of integration is Magento Order Management, so which is also Magento product. And Magento Order Management actually doesn't want to provide any source manipulation on the level of Magento. So all the manipulation should be done on the level of Magento Order Management. That's why, for example, merchant in this case would not deploy modules with admin UI at all, and because all the admin manipulation would be done from the side of Magento Order Management. That's why you can consider MSI as MSI headless plus UI, and for headless UI we have a dependency on sales, catalog inventory, legacy, store, and all product types. But if merchants would like to use MSI UI, which is also provided as a part of MSI, there would be additional dependency on UI module, backend, reports, directory, and shipping. So it's pretty interesting. And here you see the straightforward diagram of the microservice implementation of MSI and Magento. So this is probably all regarding the webinar, and probably we're already out of time, so I'm not sure that we have a time for asking question. So probably, but you can reach me by email or in Twitter or in the community Slack channel. But if there are guys who are not in a hurry and have question and ready to ask them now, feel free to do it, and I will try to answer.
Hi, can you hear me?
Yep.
So I have a question concerning the dependency injection.
Yep.
Why on the Magento you did not, because I use the dependency injection in the Scala and Java, and it is possible to, instead of use a constructor dependency injection, to use directly method dependency injections. I don't know if you're familiar with the.
Yeah. I'm familiar with both Java and Scala, and also, for example, if you consider dependency injection used in Symfony or Zen frameworks, this dependencies injection also support setter dependency injection. So it is possible to change the state of the object after it was created.
Yeah.
But actually, the existence in Magento just a constructor dependency injection is not a feature gap, but a feature, because what it actually means if you have constructor dependency injection. Actually, it means that after creation, your object already have all needed dependency.
Yeah, but sometimes I don't need all the dependencies loaded at the initialization of the object. I just need it on a certain method because, for example, if I want to use some helper, and I load a very big object like order objects,
But actually,
yeah,
and I understand what you mean. But actually, it just violates that your current object has some problem with the design. So we have a gut object which has a lot of method, and this object violates some of the solid principles.
Yeah. I just became aware of that, but I mean, you found from what I'm hearing from you, there is not really a solution because, like I said, my problem is with the helper, and I have, in fact, it's a helper which helped me to synchronize orders and stock to some external services. So I need the objects I'm loading, even if they are heavy. I cannot really isolate them, like separate them in different helpers. I don't know if I'm clear enough, but
from my perspective, at least, if I understood you correct, you want to transfer data from one system to another system.
yeah.
If in this case, I'm not sure that order model is the correct way for this. So actually, you need something lightweight like a DTO of order. And you can retrieve it from, so you are not supposed to use a domain model in this case.
Yeah, I understand. Okay. All right, thanks.
Thank you for your question. Is there any other question?
Yes, one last question concerning MSI.
Yep.
At the end, you said that we can load like the UI model and the headless model, if I understood correctly.
Yes.
But how will we manage if I do a migration from Magento to that one to the latest with MSC? How and how can I just load the headless, because I will need also the UI. I don't know why you separated the two of them. I don't see the.
So the main idea here is that so inventory There are a lot of different schemas how the inventory can be integrated with external ERP systems. And for some of this integration, Magento can be considered as a source of truth for order management. For other synchronization schema, even Magento could be considered as a source of truth for source management and the stock management.
Right.
But for other synchronization schema, all the source and stock management can be responsibility of external system. So in this case, we no need to provide in Magento any UI which provides source and stock manipulation, because in this case we will end up with a bidirectional synchronization. So Magento is supposed to send data to ERP system, and also ERP system will send data to Magento. So it's very complicated to support the bidirectional synchronization. That's why we provide all the UI for all the admin UI. And actually, we would not make any differentiation at the time of the migration. So all the admin UI modules would be switched on.
Right.
But it's the responsibility of the system integrator. So if the system integrator, for example, make an integration with Magento order management system, which use own UI, so this system integrator, this developer will just disable all these UI modules.
All right.
So,
And, all right. One last quick question concerning MSI, because I'm having the issue now. It's when the customers buy two products from in the same order from two different sources. So today I suppose you merge. It will stay in one order only. But is it possible with MSI to separate, to create at order creation two orders, one for each different sources, or you just have one order for the old
I got your question. Yeah. So currently, as I showed here, so probably, yeah. Let's consider here. So currently, our front end works with not sources, but with stock instead. So when we place order, we just say that we created particular reservation in a given quantity. In our case, it's -5 for a particular SKU on a particular sales channel, so on a particular website. And that's actually all. So we know nothing about the sources which would be used underneath. And we get the awareness of sources just at the time when we start to process this order. So replying to your question, actually we apply source selection in the scope of the order. So if we place this order like just imagine here we have an order which contains two products, and the first one was bought in a quantity 25, another was bought in a quantity of 10. Yeah. And there are three different sources from which this product could be delivered. So actually here on this stage we will already place an order, so we work in the scope of this particular order. And now when we will create a shipment, so the shipment document has a limitation, so it's supposed to have one from and one to points. That's why we will create here, we will choose a source, for example, Germany, and we will create the particular shipment for each particular source.
All right.
So we will end up with creating several shipments in the scope of one order, and each of these shipments will make a shipment from different sources.
All right. So you select the sources after the order, after
Yep.
the reservation.
Exactly.
And
Exactly.
but what happens if in the physical store they already sold the product, like
Yeah.
in Germany, instead of 100, now in reality there is only let's say 10 left.
So let me rephrase your question. How do we prevent the overselling?
Yeah.
So actually, we use a reservation mechanism for this. So as you can see, like here, like we placed one reservation for -5, and our sellable quantity now 10. Even so, we did not update the data in a stock. So if we consider that, for example, another customer comes to our website and he wants to buy 15 items of this product, he would not be able to do this because our saleable quantity now is 10. So it contains 15 plus -5. So we already reserved 5 items for the first customer who placed an order first.
All right. That's Mike. It does not answer fully my question, but yeah, I get the solution, because my issue was with the actually the physical source. Like if I have an external service which I synchronize with Magento.
Yeah, I got your part. So
yeah. So instead of, I believe like your solution is to say to Magento and to the external system, like if you have 100 product, let's make a reservation for 100 product, sellable product there, and in summary, it's okay. I get it. I will find a solution for my
yeah.
issue.
So actually, there is no like proper answer on to your question, because it's really dependent on how you make a synchronization with external system.
Yeah.
Because whether you allowed or not to make a synchronization when you have an open reservation, because you may take this reservation into account, or you can just ignore them. So that's you are in charge whether to take them into account or not.
All right.
That's actually, there is no proper answer, because the proper answer would be dictated for particular schema of the synchronization with the external ERP system.
Yeah. All right. Thanks.
You're welcome. Are there any other questions? If not, thank you, guys. You can reach me by email or in Twitter, and you can ping me there with your questions, and I plan to answer there. And thank you for your time, and thank you for your attention.
Thank you, Igor. It was a good presentation.
Thank you. Bye.
Thank you, Igor. Bye.
Yeah, thanks a lot.